Yeah, hello. How's it going? How's it going? Solving systems of equations is where we're at. This is still 3.10. This is your math man, author, tutor, teacher, and poet, and I hope you're okay during this COVID-19 era. We're in Math 050, section 3.10, solving systems of equations. This time we're given a system. And we got to choose the point that works for the system. So one of these 4 points work. You probably can do some of this math, orally, just thinking about it. I mean, this point is 2, 4. X is always the first coordinate, right? Kind of right here with you. So X is always the first coordinate, and Y is always the second coordinate, right? So that's the case. So 4 would go right there because that's what Y is, and 2 would go right here. But 2 times 2 is 4, and 4 minus 1 is not 4. So that means this is automatically gone. What about this one? 3, 5. If I plug in 3 for and this, remember, the point that we pick got to work for both lines because both lines got to cross at that point. So both lines got to work. So A is gone, A is out, B is in. Let's see if B gonna work. So if you take 3 and throw it in there, you get 6. 6 minus 1 is 5. That works. But let's see if it works for the second one. If I throw in 3 for X, that's going to be 6. 5 for there. So that looks like that's going to work because that's 15 plus 6, which is 21. So this does work. So this is what the answer is right here for that one. So far. Two lines can only cross at one point once. So that's what the answer is. The other two will not work. So you can see why the other two work, but they will not work. Let's go to the next one. This next problem is, woo. All right. Then we got to solve the system here, but we're going to use the method of substitution. So we're going to solve the system, but we're going to solve it by using substitution. So substitution. This is the method of substitution. Now, we're going to talk about that in class, but for me to do snippets on it is just going to be problems. So I'm making up one for you right here. I want the answer to be 2, 1. That's what I want the answer to be. So the X, Y answer is going to be 2, 1. So if I make up the problem, this is the made up portion of the problem. So what I started off doing is I put the 2, gave me some space, put the 1, 2, and then another 1. So these are going to be my X and Y's, right? So I just put coefficients around it to make a true statement. So we know that negative 3 times 2 is negative 6, right? And we know, so negative 6, and this will be plus 4, which would be minus 2. So if I'm in a whole 6 and I got 4, I'm still in a whole 2. And then if I'm in a whole 2 and I got 3 1s, then I still got 1 left over, right? So when I write this stuff, I know that my X is 2. So when I rewrite this in terms of algebraic sense, that it's going to be 3X plus 4Y equals negative 2. Exactly what I got over here. And then minus X plus 3Y is equal to 1. Exactly what I got over. So this will be the system. And it'll say solve the system. And it looks like this, right? So when it says solve the system, it'll give you this and give you this system, and you got to solve it to get this answer, 2, 1. So I made it up for you, and now I'm finna solve it to see how you get it back. So the substitution will go like this. If it's solved by substitution, here's the slick move I did. I got to substitute one of these equations in for the other. So that means the quickest way to do that, though, is to get this X isolated since there's no number right here. So what I'm going to do is change the sign here and make it positive, and then I'll know what X is, and I'm going to substitute into the other one and find out what Y is, then substitute back and find out what X is. So that's what I did. So I'm going to use substitution, so I'm going to multiply everything in this equation by a negative. So it'll be the opposite of this, which is this, the opposite of this, which is this, and the opposite of that, which is that. So then I got that. Then I threw this on the other side, so add 3y on both sides. So I get 3y minus 1 on the other side. So x equals 3y minus 1. Then I'm going to take that and throw it into the top equation. So the minus 3 is there. And remember, x is the 3y minus 1, so that's there. And then the plus is there, and then 4 is there, and y is there, right? And then minus 2 is there. So you got this, right? So now I can use the distributor property. I can multiply this and this. So let me zoom in a little closer so you can see minus 3y times minus 3 times minus 3y, and the minus 3 times the minus 1. So that will give me what? Here it is. Minus 9y plus 3, because negative times negative is positive. And then the plus 4y is there. And then the minus 2 is there. Now at this move here, at this juncture, I gather like terms. I'm in the whole 9 and I got 4, so I'm still in the whole 5. And then plus 3 and then equals negative 2, right? Then I just got to solve this two-step equation. So I subtract 3 on both sides. When I do that, I subtract 3 here, it's gone. Subtract 3 here, I add keep, so I'll get negative 5, right? And so 5y equals negative 5, right? And then I divide both sides by negative 5. So that means I get y is equal to positive 1, right? So this was working out. How I made it up, and I'm just checking what I made up. And once I know y is negative 1, I go back to where I made my substitution at. Remember, we got to find out what x is. So I'm going to throw the y in there. Oh, I'm sorry, in there. And so I'll have this. The minus x here, I probably can throw it in here. So the minus x times 3 times 1, right, which is equal to 1. But 3 ones is 3. So we really got negative x plus 3 equal 1. And I got to solve this for x. So I subtract 3 on both sides. So I'll get negative x equal negative 2. But then we know x equals 2 at that point. You divide both sides by negative 1. Or you can just look at it. And you see that x is equal to 2. Right? So you can play around this, but you saw how I just made this up and made my own system up and solved it and show you how you can make these up. So math, sometimes it's backwards, man. You just got to figure it out. This is your Masters in Math instructor, aka Professor. Take care. Have a good day. We'll be back on the next snippet.